After is everyone okay if we turn off the lights?
Yeah.
Oh, you want the lights turned off? Okay.
If everyone is okay.
Yeah.
But there is too much reflection on the screen.
And then I'll start speaking. It'll be like a lullaby, and you'll all go to sleep.
Now is when we have to find
And let me start sharing my screen. One of you remotely, I just realized I hadn't turned on the sound and screen. I just did. Could one of you speak up so I know I can hear you?
Yeah, we can see it.
Yeah, we can hear you.
Okay, thank you. Thank you. I can hear you too. And you can see my screen too, I hope.
Yep, we're
Yes,
good.
we
on.
can.
Zoom link is really in the course portal. This Zoom link is working or not working for you? I can post it again. Hang on. To get the Zoom link, I need to do what? Invite. Copy. Invite link. And where should I post it? To Slack, isn't it? Will Slack do? Yeah. So I've given the Zoom link now.
So I
All
came
right,
via
folks.
Slack, Asif. So the Slack one is working.
Slack one is working. Okay. Nice. Thanks. All right, guys, welcome back to our day 3. Today, we'll start by recapitulating what we did last time. And after that, as usual, we take the first hour to recapitulate everything that's happened. And then we'll move on to new territory. In many ways, today is when we'll pick up pace and we'll start putting the pieces together. Like when you read the project description for search, the one that I gave you, I'm sure you must have had a lot of questions. How am I going to do this? Will I store the data in a database? How do I search for the nearest neighbors? Right? There must have been, I hope, a lot of unanswered questions in your mind. Anybody who had questions after that, reading that project? No one. It was perfectly clear. Okay. All right.
We had too many choices.
You had too many choices. So today I'll walk through that and I'll give you guys a lot of practical hints on how to do that. Right. Along the way, I'll introduce some new technologies, but that is it. As you notice, if you look at this, our course portal, today we are going to do 4 things actually. We are going to do something called Streamlit and Chainlit. How many of you are familiar with Streamlit? Just a couple of people, so good. Then I won't be wasting everybody's time by teaching the obvious. Then I think I saw a hand go up in remote also, or did I or not? Streamlit is an amazing framework that really, yes, one hand went up, makes it very, very easy for data scientists, for AI engineers to create UI. It addresses an essential tribal culture gap. See, the tribe of people who do beautiful UIs, they have an entirely different culture. They talk in terms of React, Tailwind, right? Next.js and Bootstrap and God knows what other things, right? Many, many things. Yes. Yes. And then the people who talk about AI or large language models and machine learning, etc., they keep talking about all sorts of things like scikit-learn, PyTorch, Hugging Face, transformers. And guys, please mute yourself. I'm getting it. Yeah. So we live in different worlds, and yet when you build a model in a real application, you do need a front end to it to see it work, to have inferences. In particular, for the project that you have received, you will be putting a user interface, or you'll need to put a user interface. Like, for example, if you have some documents that you are searching, you will need to put something there, something like even as simple as a Google search box, right? in which you ask a question and you get answers from the search results. So the ability to do that requires that you have some familiarity with UI technologies. And this is where things like Streamlit and Chainlit come to your rescue. They come to you the rescue in two ways. First is that you can continue to write the UI in Python. Are we together? And very few lines of Python, like 3 lines of Python, 5 lines of Python, can already produce a complete web app that is running. Right? It is one reason Streamlit is so popular in the data science community as a UI building framework. Right? Excellent for rapid prototyping. Likewise, if you are familiar with the ChatGPT interface, which all of you are, and you ask yourself, how do I create a conversational user interface? How do I create something that looks and behaves like ChatGPT? Right? I can upload a file, I can ask questions, and I can get answers. And it sort of looks like the very familiar interface of ChatGPT. So for that, you can use Chainlit. Are we together? Chainlit. Now, in your project, the first part of your project is take some document, search through it, chunk it, search through it, and show the search results. For that, it is a simple search page interface. You will realize that if you use Streamlit, you can literally produce the user interface in a matter of a couple of hours. Right? And you don't have to go write REST microservices. You don't have to do a lot of other things that you would normally need to do. Now, those things you can do slowly. It's a good idea to do those. If you read my document spec, you see I talk about putting together a microservice. I talk about having a database for chunks. So those are more formal ways of doing it. But it's good to start iteratively by simply taking chunks, putting it together, and then having a user interface through which you can search your embeddings. Right? So that is Streamlit. We'll talk about that. Now, when you search vectors, you realize that all your document chunks have become vectors, isn't it? When your document chunks become vectors, the question is, I have a query. The query also becomes a vector. I need to find the nearest neighbors. The search results would be the nearest neighbor vectors. When you search for nearest neighbors, you could do it by brute force, for example, hold all the other vectors in memory, all the document vectors in memory. And then when a query comes, you convert it to a vector and you compare it against all of those vectors in memory. Right? And when you do that, you can pick up the k nearest neighbors. That's the most intuitive way to think about it. But what are some of the problems that you can have if you take that approach? When you try to scale that approach to production, what exactly can go wrong? Or what are the limitations that you can face? Anybody?
It's too long.
Why would it take too long?
Your vector database is very large.
Work and square.
Right. So every query will take, suppose you have 1 million vectors, you'll have to compare it to 1 million, right? 1 million, this query vector will need to be compared to 1 million and then sorted. So there's a linear thing, and then you'll have to pick the k top results, isn't it? Out of that. So all of that is expensive. Do we agree that all of that is expensive? Other thing is you may literally exhaust the memory. You may not have memory to hold so many vectors. See, million these days is quite small. In this bootcamp, of course, you will have a few 100,000 vectors or embeddings. But in real life, in large companies, social media companies, they talk in terms of hundreds of billions of vectors and searching through them. So when you're searching through hundreds of billions of vectors, you realize that you will have a huge performance penalty. Even if you could hold that much in memory, it would be computationally brutal. Now, in production systems, can you imagine how fast the data flows? Most of these social media houses they receive close to 1,000 queries a second they are processing on their clusters, right? Queries into search indices like this. The search index that you created is used to search for things, as you know, pictures, images, text. But more than that, modern this search embedding is so powerful. Often, it is a key part of the recommender systems. Almost all recommender systems use these vector embeddings one way or the other. That's a big change that has happened in the last few years. So that means that, and how many recommendations do you put? Nowadays, it's hard to come across a page which doesn't have some recommendation system powering it. You go to Amazon, Walmart, anything, Netflix, everywhere. Recommendation systems now have been around for more than 2 decades, but they have been changing. And as new technologies come in, the underlying engine keeps changing, though the appearance is the same. The end user appearance is you get some recommendations, isn't it? Right? So we need to do that at lightning speed. So that brings us to the topic of ANN, approximate nearest neighbor. It turns out that this problem has been something that computer scientists have been thinking, and it's not so much an AI problem, but it's a problem broadly of all computer science. How do you do very fast vector searches? And technologies have been maturing for the last 2-3 decades on it, right, or more. And these algorithms, I think the earliest ANNs may go way back to 80s or early now. 80, yes.
You might need that light because on Zoom you are looking very.
Oh, I'm looking very dark, huh? Okay, sorry.
Just want to make sure the Zoom people can see you.
See me. It doesn't look like a ghost talking, huh? Is it better now? AI talking, yes. So approximate nearest neighbor, there's a whole set of techniques that you can use to do that. And then I would take you to another topic called prompting. Prompting is something we all do. You all do on the chat GPT. What you write is a prompt. You get back a response. Prompt is nothing but an input to a machine where you expect a textual answer in response. Textual input and textual output is your prompt. So we'll learn a little bit about prompting, just the very basics. Prompting is a big topic in the follow-up bootcamp, but in this one, we'll limit ourselves to the simplest of frameworks that we can use that will still make your prompting effective. Now, why are we going to prompt? Because today, time permitting, I don't know how much time will permit it. I want to introduce you to a very important topic, RAG. Did I talk about RAG last time? No. So today is a good time to introduce the topic of RAG. Are we together? And RAG stands for Retrieval Augmented Generation. So in case you have nightmarish memories of being ragged in your first freshman year of college, right? This is a different kind of ragging, but I'll make it equally bad for you. So, yes.
So we talked about ANN when we are playing with the project using the library phase. I was just looking at the code. I found some GPU references.
Yes.
Actually doing something with ANN underneath the phase library.
Yes, FAS is in fact the industry workhorse as of this moment for ANN.
Okay.
And we will talk about that. We'll talk about that quite a bit today. So we'll do RAG, time permitting. And it turns out that RAG is the destination we are going towards. All the pieces we are building, the streamlet, the chainlet, the search, semantic search that we learned so far, the approximate nearest neighbor search methods, and prompting. It turns out that when you put all of those pieces together, you get RAG. RAG is almost the poster child of generative AI. If you ask this question, what is the most prominent use of AI, of machine learning for the last 2 decades? the answer to that would be in the consumer mind, with direct impact to consumers. The answer to that would probably be recommender systems. Recommender systems are the cottage industry that drove Silicon Valley, like, all sorts of startups. You use recommender systems for advertising. You use recommender systems to recommend your music on Spotify. You use recommender systems to sell things, right? You use recommender systems to topple governments, right? By manipulating voters. You use recommender systems for just about everything, right? So it's been there for a long time. But with the coming in of large language models and generative AI, if you ask this question, that behind all the hoopla, behind all the hyperbole that you hear, what are some of the use cases that are undeniably of tremendous enterprise and practical value? What is it that companies can today? Suppose you were the CTO. What is it that you can adopt without hesitation and not lose your job for introducing something very high risk, something dangerous, right? That is mature? So what are the hallmarks of things that are mature? Proven technology with a clear benefit to cost ratio, right? With bringing about significant cost savings, bringing about significant efficiencies to your business, safe, right? So without leading to any compliance or regulatory problems or massive security risks are introduced whenever you introduce a technology, but relatively safe. You would realize that the one answer to all of that comes to be RAG. RAG has wide applicability. What is RAG and so forth? We'll deal with it in detail. We'll talk about it. That will be the paper reading for today. Okay. So we'll do RAG. Now, but before I do RAG, I'll give you a sense of where it is being used. It is being used, especially in the enterprises everywhere. Think about it this way. Today, more, and this may surprise you, I don't know if I've mentioned this fact, more knowledge is being produced every 2 years than in the entire history of mankind. In most subjects, more breakthroughs are happening in the last 2 years than in all the history of the subject. Whichever, not just AI, whichever field you look at, it seems to be galloping ahead. All of that is producing data, it's producing techniques, it's producing knowledge, it's producing documentation. The same is true for enterprises. If you look at enterprise, within your company, many products exist, you provide tech support, you provide customer service, irrespective of what you do, even if you're doing oil drilling, right, in the middle of nowhere, you still have a vast repository of knowledge which is growing to help the engineers internally. Is that true? Right? Whichever company you come to, and if you look at it, we talked about this the last time, that typically those companies have what you call basic Elasticsearch or Solar or some traditional search engine sitting on top of that document, right? Or Confluence will have some search bar or something. These are old gen techs. And one of the things we learned in our in the last two Sundays was that AI search, semantic search, is a minor improvement or a big improvement. It's a huge improvement. It's a game changer. It's a game changer. But then you take that AI search, it turns out it's a part of the puzzle. People can search for answers in documents and get it. Excuse me. But what they get are search results. Okay? Excuse me. I go out for a walk in the very, very cold early morning, and this is what I bring back for the next few hours. A bit of a sore throat these days because of the rain. So you get back search results. But when you come across Google search results, for example, don't you feel that there is still a bridge to cross? You need to study the search results and hunt for the answer that you want, right? Even if the most relevant documents, most relevant web pages have been surfaced, you still have to poke through it and extract the result, the answer that you want. True, guys? Is that a common experience? And the question is, would it not be nice if somebody read that all for you and answered the very specific question that you want? Right? So suppose, let's take a hypothetical example. You have, let's say, let's say that you're looking at, you're a physician. Imagine you're wearing a physician's hat. There comes a patient. You have been prescribing all sorts of diabetes medicines to the person. And let's say that whatever medicine you're giving, the patient is not responding to, and is still coming back with a A1C, a measure of diabetes, which is off the charts. Let's say it's at 12 or something like that. Now the question is, you want to give a medicine X, but like every patient with diabetes, there are multiple complications. Diabetes is a metabolic disorder. It never comes alone. It is a name for a host of problems. It comes with hypertension. It comes with many things, right? Impaired, it's duress on the heart, renal failure, or degrees of renal failure, and so on and so forth. You want to prescribe some medicine, but you want to know, for given this patient's history, is it safe? So let's walk our way through this scenario. Let's just say, like all physicians, you have access to a vast amount of medical data, medical textbooks. If you search for, let's say, a textbook, will it address this specific question? Probably not in the form, right? You're looking at Jerry, who is 60 years old, with this presentation, A1C 12. It didn't respond to the medicines that you gave. There are signs of heart, like cardiovascular issues already, cardiovascular damage. There are signs that there is renal distress. At that particular moment, you want to change to this medicine. What do you need? You need essentially somebody to process that information, the most relevant information, and do what? Communicate it in a way to answer one precise question. If I were to prescribe this medicine, would it be, all things considered, does the benefit outweigh the risks? Isn't it? And are there any catastrophic risks in prescribing this medicine? That's a question you would perhaps want answered. But what you would get, even with AI search results, are excellent references. Go read. Now, imagine that you're a physician. How much time do you get with a patient?
6 minutes.
6 minutes. How did you come up with 6 minutes?
I read it somewhere.
Yeah. Well, nowadays we live in this world of health management organizations and so forth, right, who actually budget the time that a physician gets. That time is split in 2 parts. Time to read the patient's chart, talk to the patient, and then everything that has happened to enter it into the computer. And entering it into the computer takes a long time. So in a very short duration, the physician has to catch up, right? Go take care of the patient and come out. In that short time, it's hardly the time needed, right, to go read copious documentations and synthesize an evaluation that, yes, I think it's okay to give this medicine. Now you can say, doesn't the experience of the physician tell it? It does, but sometimes what happens is that and this is one of the interesting things, those of you in the medical field know, that healthcare is not a hard science. It's not like physics, where you can predict the trajectory of a satellite down to 4 decimal places. In medical field, there are a lot of unknowns. So at any moment you're doing something, you don't know the exact chain reaction that you will trigger, the exact chemical pathway that it will lead to. And every human being is different. Every presentation is different. So you're taking a calculated risk with every single thing you do with a patient, especially in complicated cases like that. But you get a tiny amount of time to come up with an evaluation. This is a perfect situation for doing this. You say, you know what? Large language models are very good at understanding text because they have natural language understanding ability, right? Why don't we do this? Let us first use AI search to find the most relevant document. Then feed it to the LLM and say, hey, based on these things, how would you answer this question? Does that make sense, guys? So do you see the practicality of it? But now I'll pose you a question with this hypothetical scenario in mind. By the way, any physicians in our midst or people with medical background today in this cohort? In the last one, we had 2. No one? No MDs? No nurses? No people? Okay. But I think you all will resonate. It's a common situation I'm talking about. Correct me if I'm getting some medical facts wrong. So now I'll pose you guys a question. Why, if the LLM has been trained on all of world knowledge and therefore has already been trained on all of the world's medical textbooks as public, why can't I just ask the LLM directly? Why do I need to say, based on these facts, answer this question? The LLM already knows. If you don't have to, when you go to ChatGPT, you don't have to tell it, give it any information. You say, hey, my big toe hurts, right? Should I take a Tylenol or not, or whatever it is? I'm just creating a simple scenario. You do ask it, and it comes up with a reasonable answer. Right? And there are safeguards put behind the LLMs that protect it from giving bizarre answers. I mean, the 3 things that you shoot for with LLMs, people formulate it in different ways. Anthropic, for example, poses it as the 3 H's. All these LLMs, the creators, the programmers, they have programmed it to honor 3 H's, roughly speaking. The responses must be honest, the responses must be harmless, and the responses must be helpful. Right? So honest and harmless response, but not helpful, doesn't serve you. Like, for example, it says, my left toe hurts, and you say, yes, today is going to rain. So that's not quite helpful. Right? So you do all of that. Now the LLM comes up with an answer. Why do you think you still would want to back it up with extra knowledge? Noise of what?
I mean, LLMs are learned based on the entire knowledge, but they may be wrong documents.
Yeah, the LLMs have learned from gazillions of documents and textbooks. But how does that create noise? I mean, it may have an IQ that is 1 billion, and it may have perfect understanding of all those documents.
In medical field, this theoretical knowledge is not sufficient.
Good. Theoretical knowledge is not, experience matters, exactly, because it's not a watertight domain. But it has read through a lot of case histories, and it remembers how the best physicians handle situations like this. So it can do a monkey see, monkey do. Right?
So we need to give it context, right? So for example, let's say my toe hurts. Am I talking from a gym or from a doctor's office or a yoga place? So doesn't know, right? So we need to give some context.
Some context.
To set the.
Yes, that's a good answer and part of the right answer. That you may not have given enough context, but let's say I do that. In the prompt, I say, this is who I am. This is my current situation. And now, what is your answer?
Is it that LLMs have been trained on a snapshot and they don't know the recent information?
Good. That's another part of the answer. So you guys are all putting all the big pieces together. Context is important. You gave up too easily. You could argue on the context with me. But actually, context is part of the right answer. Recency, the fact that LLMs were trained on a particular day, and anything that happened after that day, because LLMs are prohibitively expensive to train. As you know, to train an LLM takes months and as much electricity as a whole city consumes, mid-sized city consumes. You get some, yeah.
I mean, the question is like, you go to the knowledge base and then search for the.
Yeah, why would I go to the knowledge base? Why would I search for something? Yeah.
The LLM is based on the fact of the, and the knowledge base is more of a reference.
Partly getting there, but you have to sharpen the wordings a little bit. Yeah, go ahead.
Quick question. We had this thought last week too. The LLMs, once it is trained, is there a way to incrementally train it more, or you have to
No.
train it before?
Generally, once you train a machine learning model and you put it for inference, you don't keep training it on the job. You train a different model and then deploy it later with new data. So anybody else would like to take, people remote are very quiet. Anybody from the remote, from the Zoom would like to speak up. Why in the world, when the LLMs are practically omniscient, right, in knowledge they are the gods, why do we need to give them extra info? Yeah, go ahead.
When I go to doctor, even with this expo, I go with microhertz, he would ask questions. Based on the questions, he's asking different questions, and then he gathering data.
Right.
And that's probably that's like a phase of forming the question.
That is right. No, that's a very good point. From the audience, I got this response, which is actually again a big piece of the correct answer, is that the doctor engages. It's a conversation. It's a consult. Ask you questions, and as you answer those questions, those are guided questions. They help the physician go through a process of differential diagnosis. What really is the root cause and what you should do. But so can the LLM do that process of interrogating? You can prompt it to go through a process of interrogation with the patient. In fact, many startups are trying to do something like that. It's one of the big frontiers for the LLMs these days. So again, I'll bring you back to the question, what use is AI search anymore? Let me pose it this way. Have we just learned a perfectly useless technology, AI search? In the world of LLMs, when the LLMs know everything and remember everything and understand everything, what is there left to search? You can just ask the LLM.
You're bounding the search.
You can do that. Like, for example, when you're in the kitchen, even though you know all about computer science, you focus your knowledge only to culinary art. Yes.
So the question kind of assumes when I'm searching, I know what I want, which may not be true. Like I might go to a shop and say, okay, I'm looking for a bookshelf. And I go there, I look at different things, and I might come out with a bookshelf plus a desk together.
More things for that. We're sort of hinting that, guys, think of structural problems with LLMs. What exactly are the big problems we are facing with LLMs? Go ahead.
Is it trying to validate from the knowledge base what the LLM output is?
Yes, sort of. See, guys, you all have hit upon the right answers, but in different pieces. It's somewhat like the accuracy is a concern. Again, a good point. Anybody from Zoom would like to speak up or throw in their hat?
So one more issue I see is just so whatever the training, irrespective of like whatever the situation is, it will just give a very predictive answer which might not be fulfilling the actual diagnosis.
Yes, that too is a point. Okay, so let me get you this situation. See, guys, so let me give you some of the reasons. First is LLMs have been trained on all data. Well, that all data is a qualified all. What data has it not been trained on?
Private data.
Private data that is specific to your company. Right. So if you, like, for example, if you're an oil drilling company, guess what? Or if you are a Boeing, do you think all the engineering specs of the wingspan manufacturing are public? Or if you're the maker of F-35, are they all public? Of course not. They're strongly guarded secrets. So if you have questions about them, the LLM would be silent. The problem is, silent is the best case situation. LLMs are very, LLMs are created by engineers, isn't it? And they reflect the personality of engineers. Have you ever come across an engineer to whom you gave a problem, and the answer to that is, I don't know? Engineers always know. They say no problem, and they'll produce some answer to every question, isn't it? Right or wrong, they always have an answer. It's part of a personality, I suppose. So these LLMs do the same thing. You ask it a question, unless you really say, if you don't know, be absolutely, even a little bit of hint, say I don't know. Even then, they're trigger happy. They will respond with some answer. They'll just make it up. And the reason for that is LLMs are plausibility engines. They are not truth engines. It's a key differentiator. LLMs are next word predictor. What is the next word prediction engine doing? It is predicting the most likely next word. It's producing word after word after word that to you looks like sensible. Right? But internally, it's a state machine that just produces the most likely next word. Likely for what? Likely to be a plausible part of the answer. Right? And as such, they are plausibility engines, never truth engines. Right? And that little differentiation matters, because what it means is if it doesn't know, or if it has half knowledge, partial knowledge, it will confidently answer it anyway. Are you together? It will produce a text that somehow sounds like the right answer. And that is a big problem with LLM. So how can you fix that? That is one problem. The second thing is, how can it answer questions, especially about things it has never seen? Third is this recency problem that one of you brought out. If a LLM was trained in 2021, much has happened since the last 2-3 years. How will it answer questions about more recent developments? And lastly, the problem is when people prompt, users prompt, they don't give enough context. And so maybe for the LLM to answer the question properly, it needs enough context. All of those reasons argue for augmenting the LLM input with what?
More information.
More information. You need to do in-context learning. Means in the prompt itself, you say, here are new facts that you may not know. Right? Base your answer, whatever the user asks, base your answer in view of these facts. Does that make sense? Right? So one simple example could be, and this became very popular these days, there were a bunch of startups that said, oh, you could talk to your PDF document. How can you do that? You take the whole PDF document, convert it to text, put the whole thing into the prompt, and say, given these facts, how do you answer any user question? So the user puts a question, but behind the scenes, the question is prepended with the entire text of the PDF, goes to the LLM, LLM reads the PDF, reads the text, and says, aha, it's easy to answer this question. Isn't it? Do you see that, guys? Even though it has never seen that PDF or that set of facts, because it has language understanding capabilities, and it answers that. That is a classic example, a very effective but almost dead simple example of RAG. Right? So there are some people who try to monetize that. There are companies that came out. There was talk to your PDF. Lots of little startups and websites are there. You can try it out, but at the end of it, it's just a simple RAG implementation. Right? Done well, but done well, it is so effective.
So how many companies will expose their private data to LLM and deploy AI in their.
Yeah, Prashant has a very good question. How will companies take their private data, confidential data, and expose it to LLM? Right? The answer to that is, see, there are many, this is a nuanced question. This is the first question that came, that when you use ChatGPT or Gemini or any of this, your data is going over the wire outside your intranet, right, inside your confidential zone, to these places. There it is being processed, and now the LLM knows. And there was a famous case, I believe it was it Samsung or some company, where the employees literally uploaded the blueprint, engineering blueprints to ChatGPT and asked questions, right? And ChatGPT's user agreement clearly said that anything you upload to us is ours. We have a right to use it. Right? So that highlighted that people don't know how to use these tools yet. We are all learning about it. Right? Now, how should it have been done? There are two ways of doing it. First is have a private LLM in-house. When you have an in-house LLM, then data never leaves your house. You search in-house and you feed it to the LLM in-house and you get a response. Are we together? And in fact, in this project, that is what you will do. Use an in-house LLM, an open source in-house LLM to do it. Start by using OpenAI just to get your feet wet. And once you have figured it out, once you have become good at it, use an in-house LLM. It's easy. These days, installing and running an in-house LLM, like open source one like Llama 2, etc., is one liner. And I will give you the tools. Ollama is a good tool. Right? Especially on Linux, it's just a DNF install, yum install. And once you have installed Ollama, all you have to say is, Ollama run, and you give it a LLM name, let's say Llama 2 or Zephyr or whatever it is, right? Or Mistral. That's it. And if it is not there on your machine, it will go download it and it will run it for you locally. And then you can engage with it. So things have gotten quite simplified, actually, with all these technologies coming in. You can run all of that in-house. So, all right, guys, that's a broad context of topic for today. RAG, yeah.
So question on that, how big can the private data or that extra source of information, how big can it be?
Yes, I have a question from the audience. Vasanthi asks, how big can the database or the corpus of information that you RAG or you search from be? The search technologies, and this is one of the things you learn, the impressive power of ANN machines, ANN engines these days, and vector databases is such that if you're talking hundreds of billions, it's a piece of cake. Right? So realize, guys, that the modern technologies are being framed and created for web scale data. In front of web scale data, what is traditionally called enterprise data, what stays within any company, however big, is a drop in the ocean. So without exaggeration, one can say that enterprise data is tiny data, right? Because, and all these technologies, they just chomp through it. They work to give you an example, if you take any, and I have done an enterprise deployment for one company. So for when you do RAG, the search index, even if it contains something like, in this particular case, contains something like 70, 80 million pieces of documents and images and things like that, any one query still returns in, like the search results return in less than 30, 40 milliseconds. Right? So, and most of that time is the network traffic time, IO time. So these engines are insanely fast and insanely scalable, especially the one we'll talk about, FAS, for approximate nearest neighborhood. It is almost, it is the culmination of years and years of research from many, many people. And then Facebook put it all together into FAS. Right? Like it's like standing on the shoulder of giants, and it's become an industry standard to use FAS. And like no one has ever complained that, oh gosh, FAS is slow. That day is yet to come. Yes.
So if you have the RAG, is it going to limit the search space to the RAG, or is it like an augmentation to the LLM?
No, see, and we'll talk about it in the RAG paper, which you do. See, LLM can answer things from its own memory. It's called the parametric memory. And it can answer in a RAG system based on what it has been given as search results. That is the retrieval memory, or retrieval, yeah, from your corpus of documents and images and videos and audios. It can do that. Yeah. Now, generally, it mixes the two up. If it doesn't find the answer in your documents and you're not careful with your prompt, it will start using its own memory to answer the question. Right? So you get both. You get the benefit of both. And in particular, you mitigate hallucination. Because if the LLM knows the facts, it's less likely to hallucinate. Yeah.
What's the difference between RAG and fine tuning? So in an enterprise context, when you take an LLM,
yes,
and then you feed it your data, so now it knows your company's data as well. Now, is RAG over and above this?
Yes, RAG and fine tuning are two orthogonal topics. See, RAG in some sense is, and in fact, quite often you make a choice between RAG or fine tuning. Right? Fine tuning is to say, I have a model and I am going to further train the model with some data. Whereas in RAG, what you say is that the model, let it be there. I'm not going to fine tune it. I'm not going to further train it. But during runtime, I'm going to prompt it with additional information. So no further training. So the word people use is in-context learning. You're literally doing in-context learning. You're giving it information. Say, learn from all these facts and now answer my question. You already know a lot, but it has some additional things for you to learn. So it is in context.
But that would mean that, again, when you're looking at how to run this in an enterprise context, user enters a prompt.
Yeah.
And there's got to be a step in which we retrieve the relevant context using some mechanism, maybe a semantic search, and then feed that to the main LLM.
Yes.
So, okay, now here's a set of documents that was from the basis of your response to me, right? In addition to what you natively know.
Yeah, yes, exactly. And that is RAG. That's exactly what RAG is.
It's like a GSLV for a network. You route which server the data has.
Yeah. Right. Okay. Yeah. Yeah. Good, guys. And so that's the scope for today. I gave you a broad picture. Go ahead.
That's in full this bootcamp. Are we going to limit ourselves only to the RAG, or will be like getting into fine tuning? Because RAG, if you consider that one, is 80% software engineering, 20% of some of the measurement. Because and then understanding about the semantic search, but and then after that, okay, we are going to use the existing ones.
Right. So the question that I got from the audience, I'll repeat it for those of you who are remote, is that in this bootcamp, for the rest of the bootcamp, is RAG the main thing that you'll be doing throughout, or are we going to do any fine tuning or anything else? Right? So who would like to venture a guess? Roman.
I'm assuming you're going to do a little bit of both.
How can you do it? It takes a binary answer. Either I only do RAG or I do RAG and other things too.
Maybe other topics too.
Other topics too.
Yes.
Actually, true. We have a pretty vast syllabus to cover. How much we cover depends on the pace at which you absorb. I always keep it adaptive, but we are going to do very exciting things. We are going to do multimodal learning. We're going to deal with images. We're going to deal with videos. We're going to deal with speech to text to speech. We are going to do adversarial learning, adversarial attack on these elements. Right? So you can do document AI. So suppose I give you, I wish where are the crooked texts when I need them? Okay. Can you, for example, have a computer vision, look at the globe with all the text written sideways and all sorts of it, and be able to read off it? Document AI. You'll be, so we will be doing a pretty large slice of AI spectrum. Fine tuning is a part of it. With that too will do, but we won't just do RAG and fine tuning. You will be doing a lot of things. Okay? And I mean it, the pace is going to pick up now. As you noticed today, I brought a lot to the table.
Asif, I'm struggling to understand the value of fine tuning given that RAG can take in vast amounts of information. So why would you want to go through the effort of fine tuning on one?
Yeah, Shinti asks, why would what's the value of fine tuning if a LLM can take vast amount of information and answer the question? Right? See, there are certain class of problems where RAG doesn't quite help. I'll give you an example. Suppose I were to ask you that, all things considered, predict in this LLM using an LLM, right?
Asif, sorry, can you please ask the Zoom participants to go on mute?
Guys, please do go on mute. Let me put them on mute, whichever isn't. Who is not on mute? I apologize, guys. All right, I think now everyone looks on mute. So here's a very basic question. Suppose you have an LLM and you're doing something. Let's say you're doing genre of text detection. Is it poetry? Right? Or is it or what form of poetry is it? Is it haiku? Is it sonnet? Right? Is it blank verse, like Shakespearean plays? But what is it? No. Or you want to go even deeper into it. What is the meter? Is it the iambic meter and so on and so forth, that all the terminology and technology poets use? Then how can you give more? Like, this is not something that is knowledge based. It is something that the model needs to discriminate between this and that. Right? Generally, fine tuning are much better at these tasks. Or another one of them would be, if you look at toxicity in text or bias in text, you realize that you cannot say, these are the comprehensive illustration of bias. Therefore, tell me if the following text has bias. You could do that, but it is far more efficient to just fine-tune a model to predict bias.
I saw a post that somebody asked Justin about Mother Teresa fighting poverty. He come up with a picture saying that, okay, Mother Teresa is literally like doing the kung fu pose with some African kids. So basically, like, it took like fighting Mother Teresa and poverty depict that picture of like South African kids. So it's, that's the context it has.
Right. So see, fine tuning and RAG, they are orthogonal. You have to know what to use. It's somewhat like, one second. It is somewhat like, when you're cooking, you don't say that, I love cooking, by the way. So I keep taking examples of cooking. Right? So, I made, let's say that you said, I just made sambar. Now, why do I need to use rice anymore? They have entirely different purposes. Right? So you have to pick the right tool or the right things. All right, guys, that is it for today. That's a score for today. And again, in the introductory session, what did we do last time? We talked about attention is all you need. You will see that that is there. Attention is all you need is here. And this is a little summary of that paper. This is the video session and this is the paper. Right. So what is missing here in the blank spot is a quiz on the thing. And that quiz will get generated shortly in a day or two. Right? In fact, it is generated. It just not made its way automatically into the portal because I'm still putting the portal together. So this is the scope. And today what we'll do is, let us start with something very simple. We'll start with Streamlit and Chainlit. But before I do that, let's take a 5-minute break. Go get your coffee, guys, those of you who came recently. And now it will get into the academic, into the topics. Yeah.